Welcome to Web Lizard Lab's CERT Lab. This is AZ-104, Practice Exam 5, App Service and Containers. You will work through 32 source-backed administration decisions across Azure Container Registry, container instances, container apps, and app service. How this practice exam works. You will hear the complete scenario, task, and every answer choice, action, or matching target. After lock in your answer, you will have 3 full seconds of silence. Then the answer will resolve in place, followed by the reason it fits and an administration pattern you can reuse. Pause whenever you need more thinking time. If you enjoy our videos, please like and subscribe to support the channel. Question 1 of 32. A company is provisioning an Azure Container Registry. Images must remain in the company's approved Azure region. The registry must support private endpoints for a planned private access design. No container workload is being deployed at this stage. Which registry configuration should you select? Answer A. Create the registry in a different region by using the premium pricing plan. Answer B. Create the registry in the approved region by using the standard pricing plan. Answer C. Create the registry in the approved region by using the premium pricing plan. Answer D. Create the registry in a different region by using the standard pricing plan. Lock in your answer. Answer C is correct. Create the registry in the approved region by using the premium pricing plan. Registry provisioning selects both a location and a pricing plan. Premium supplies the required private endpoint capability, and choosing the approved region satisfies the image location constraint. These settings provision the registry control plane without creating a container workload. When provisioning a registry, evaluate location constraints and registry SKU feature boundaries independently. Runtime hosting settings do not satisfy either decision. Question 2 of 32. An Azure Container Registry uses ABAC registry plus ABAC repository permissions mode. A workload's Microsoft Entra identity must pull images only from the Team API repository. The identity must not push images, administer the registry, or receive access to other repositories. Long-lived registry administrator credentials are prohibited. Which role assignment should you create? Answer A. Assign Container Registry Repository Reader to the workload identity without an ABAC repository condition. Answer B. Assign ACR to the workload identity at the registry scope. Answer C. Assign ACR push to the workload identity at the registry scope. Answer D. Assign Container Registry Repository Reader to the workload identity with an ABAC condition for the Team API repository. Lock in your answer. The supported answer is D. Assign Container Registry Repository Reader to the workload identity with an ABAC condition for the Team API repository. For a registry in RBAC Registry plus ABAC Repository Permissions mode, Container Registry Repository Reader grants pull-oriented data plane read access without control plane or write permissions. Adding an ABAC condition for Team API narrows the assignment to the required repository. Check a registry's permissions mode before choosing its data plane role. Then narrow the assignment to the smallest repository or registry boundary the workload requires. Question 3 of 32. An Azure Container Registry has retained tagged images and untagged manifests. A cleanup policy permits removal only of untagged manifests older than 30 days in selected non-protected repositories. An approved repository filter excludes protected repositories, and its tag expression deliberately matches none of the retained tags. Before any deletion occurs, an administrator must review the exact purge selection. The cleanup must then run every Sunday at 01 o'clock UTC, and the configured recurrence must be verified. In which order should the administrator implement the cleanup? Answer A. Use AZ-ACR task show to confirm the timer trigger on the cleanup task. Answer B. Create an ACR task for the required weekly time, preserving the reviewed filter ago 30D and untagged settings, but removing dry run from the scheduled command. Answer C. Run ACR Purge on demand with the approved repository filter and non-matching tag expression, ago 30D, untagged, and dry run. Confirm that only eligible untagged manifests are reported. Lock in your answer. The correct order is: first, run Across Purge on demand with the approved repository filter and non-matching tag expression, --ago 30D, --untagged, and --dry run. Confirm that only eligible untagged manifests are reported. Second, create an ACR task for the required weekly time, preserving the reviewed --filter, --ago 30D, and --untagged settings, but removing --dry run from the scheduled command. Third, use AZ-ACR task show to confirm the timer trigger on the cleanup task. First, run Across Purge with the approved repository/tag filter, --ago 30D, --untagged, and --dry run. The non-matching tag expression keeps tagged images outside the selection, while --untagged and --ago select only age-eligible untagged manifests in repositories admitted by the filter. After reviewing the dry run output, create the scheduled ACR task with the same filter, age, and untagged settings, but without --dry run so that deletion can occur. Then use AZ-ACR task show to verify the timer trigger. Source freshness note: as of August 24, 2026, Microsoft documents ACR Purge as a preview feature. The sequence tested here, dry run the purge selection, schedule the reviewed task without dry run, and then verify the timer trigger, remains documented. Preview behavior can change, so verify its current status before production use. Validate the age-bounded untagged selection without deletion, remove --dry run when scheduling the reviewed settings, and create the recurring task before inspecting its trigger. Question 4 of 32. A company will run a single-purpose task in Azure Container instances. The task has a specified image, command, environment value, and fixed CPU and memory requests. A failed process must run again, but a process that exits successfully must not restart. Which container group definition meets the requirements? Answer A. Set the image, environment value, CPU and memory requests, and restart policy to on failure, but omit the specified command. Answer B. Set the image, command, environment value, CPU and memory requests, and restart policy to on failure. Answer C. Set the image, command, environment value, CPU and memory requests, and restart policy to always. Answer D. Set the image, command, environment value, CPU and memory requests, and restart policy to never. Lock in your answer. Choose answer B. Set the image, command, environment value, CPU and memory requests, and restart policy to on failure. The ACI deployment definition can set the image, command, environment variables, and per container CPU and memory requests. On failure applies to the group and reruns a process only when it terminates with a non-zero exit code, matching the task's completion semantics. For an ACI task, define its runtime properties at container group creation and choose a group restart policy from the process exit behavior, not from replica scaling concepts. Question 5 of 32. A Linux container in Azure Container Instances writes application data to /data. The data must remain available after container restarts, crashes, stops, and replacement of the container. An Azure file share and its required storage information are available. How should you configure the container group? Answer A. declare an Azure FilesBack group volume and mount that volume in the container at /data. Answer B. Declare an Azure FilesBack group volume, but omit the container's volume mount entry. Answer C. Declare an emptyDir group volume and mount that volume in the container at /data. Answer D. Declare an Azure FilesBack group volume and mount that volume in the container at /cache. Lock in your answer. Answer A is correct. Declare an Azure FilesBack group volume and mount that volume in the container at /data. An Azure file share is external persistent storage for an eligible Linux ACI container. The container group volume declaration identifies the share, and the corresponding volume mount makes it available at the application's required /data path. Persistent ACI file system data requires both an eligible external volume definition and a matching container volume mount at the path the application uses. Question 6 of 32. A Linux application container and a sidecar must run in Azure Container instances with one shared group lifecycle. The sidecar writes temporary files that the application reads. Storage must be writable and local to the container group, and the solution must not provision an external persistent storage resource. Which deployment definition should you use? Answer A. Place both containers in one ACI container group, declare one emptyDir volume, and mount it only in the sidecar container. Answer B. Place both containers in one ACI container group, declare one emptyDir volume, and mount that volume in both containers. Answer C. Place each container in a separate ACI container group and define an emptyDir volume in each group. Answer D. Place both containers in one ACI container group and mount the same Azure file share in both containers. Lock in your answer. The supported answer is B. Place both containers in one ACI container group, declare one emptyDir volume, and mount that volume in both containers. A multi-container ACI group gives the application and sidecar a shared group lifecycle. An emptyDir volume is group local, writable, ephemeral storage. Declaring it once and mounting it in both containers lets the sidecar write files that the application reads without provisioning an external persistent storage resource. Use one multi-container group for a shared lifecycle and mount one emptyDir in every container that must exchange group local ephemeral files. Question 7 of 32. A company is creating a container app in an existing container apps environment. The application listens for HTTP requests on port 8080. Only other container apps in the same environment may reach it. Direct public internet access is prohibited. Which app provisioning configuration meets the requirements? Answer A. Place the app in the existing environment, enable internal ingress, and set the target port to 8080. Answer B. Place the app in the existing environment, enable internal ingress, and set the target port to 443. Answer C. Place the app in the existing environment, enable external ingress, and set the target port to 8080. Answer D. Place the app in the existing environment, disable ingress, and set the target port to 8080. Lock in your answer. That makes A correct. Place the app in the existing environment, enable internal ingress, and set the target port to 8080. Internal ingress limits the app's FQDN to callers in the same container app's environment. The ingress target port must be the port on which the container listens, which is 8080. Container apps ingress provides the incoming routing without requiring a separate load balancer or public IP resource. For container apps ingress, choose internal or external exposure from the caller boundary and set target port to the container's actual listening port. Question 8 of 32. A container app has one active revision. Its next revision must supply a database password through dbPassword. The password must not be embedded in the container image or entered as a plain environment variable value, and no container app secret currently holds it. You will use the Azure portal. In which order should you complete the entries and action? Answer A. Revision environment variable, name equals dbPassword. Source equals reference a secret. Secret equals dbPassword. Answer B. Revision operation, create. Answer C. Application secret. Name equals dbPassword. Value equals the database password. Lock in your answer. Use this sequence. First, application secret, name equals dbPassword. Value equals the database password. Second, revision environment variable, name equals dbPassword. Source equals reference a secret. Secret equals dbPassword. Third, revision operation, create. Define dbPassword as an application-level container app secret first. A revision environment variable can then use reference a secret and select dbPassword because the name secret already exists. Create the revision from that configuration. At runtime, dbPasswords is populated from the secret value without placing the value in the image or entering it as a plain environment variable value. A revision environment variable can select a named application secret only after that secret exists. The revision is then created from its configured template. Question 9 of 32. A container app is running a stable revision. A new container image must be validated with a small portion of production traffic while the stable revision remains active for immediate rollback. The app's deployment template will identify the new image. Which rollout plan should you use? Answer A. Use single revision mode. Update the revision scoped image configuration and split traffic between the stable and new revisions. Answer B. Use multiple revision mode. Restart the stable revision after changing the image reference and split traffic to the restarted revision. Answer C. Use multiple revision mode. Push the new image to the registry without updating the app and split traffic to a new revision. Answer D. Use multiple revision mode. Update the revision scoped image configuration to create a new revision and split traffic between the stable and new revisions. Lock in your answer. Answer D is correct. Use multiple revision mode, update the revision scoped image configuration to create a new revision, and split traffic between the stable and new revisions. A revision scoped image change generates a new immutable revision. Multiple revision mode permits the old and new revisions to remain active concurrently and supports traffic splitting, which provides the required validation and rollback posture. Use a revision scoped template update to create a deployment version, and choose multiple revision mode when old and new versions must remain active for traffic splitting or rollback. Question 10 of 32. A workload will run in Azure Container instances and has validated peak CPU and memory requirements. The requested combination has been confirmed against quota and availability in the deployment region. The workload does not require horizontal autoscaling. The company also wants the correct procedure if the resource size must change later. Which sizing plans should you use? Answer A. Set minimum and maximum replica values on the ACI container group and let replica scaling select its CPU and memory. Answer B. Set the required CPU and memory requests for each container in the deployment and modify those resource properties in place if they must change. Answer C. Select a higher Azure Container Registry pricing plan and let registry capacity determine the container group's CPU and memory. Answer D. Set the required CPU and memory requests for each container in the deployment and delete and recreate the container group if those resources must change. Lock in your answer. The supported answer is D. Set the required CPU and memory requests for each container in the deployment, and delete and recreate the container group if those resources must change. ACI uses per container CPU and memory requests in the container group deployment to allocate fixed compute. Regional availability and subscription quota constrain the request. CPU or memory changes require deletion and redeployment of the group rather than an in-place property update. Treat ACI compute as fixed per container deployment requests. Confirm regional capacity before provisioning, and plan to recreate the group when CPU or memory must change. Question 11 of 32. A container app processes intermittent requests. During quiet periods, the app should contract while keeping one warm replica available. During bursts, it can add replicas, but a downstream service cannot support more than 8 concurrent replicas. The CPU and memory allocated to each replica are already correct. Which minimum and maximum replica configuration should you apply to the container app revision? Answer A. Set the minimum replicas to 1 and the maximum replicas to 8. Answer B. Set the minimum replicas to 0 and the maximum replicas to 8. Answer C. Set the minimum replicas to 8 and the maximum replicas to 8. Answer D. Set the minimum replicas to 1 and the maximum replicas to 12. Lock in your answer. That makes A correct. Set the minimum replicas to 1 and the maximum replicas to 8. The replica limits define the horizontal operating envelope for the revision. A minimum of 1 keeps an instance running, and a maximum of 8 enforces the downstream service's hard ceiling without changing the already correct per replica resources. Translate an always warm requirement into the lower replica bound and a dependency protection requirement into the upper replica bound. Question 12 of 32. A container app has a system-assigned managed identity and fixed minimum and maximum replica limits. The identity has already been granted the required data plane access to an Azure queue storage queue. The storage account is orders store, the queue is fulfillment, and the app must scale when queue length reaches 20. Queue credentials must not be stored in the app. Which scaling configuration should you deploy? Answer A. Create a custom rule of type Azure Queue with the same metadata and auth that references a stored queue connection secret. Answer B. Change revision traffic weights whenever the fulfillment queue contains at least 20 messages. Answer C. Create an HTTP scale rule with request concurrency 20 and identity system. Answer D. Create a custom rule of type Azure Queue with account name order store, queue name fulfillment, queue length 20, and identity system. Lock in your answer. Choose answer D. Create a custom rule of type Azure Queue with account name, order store, queue name, fulfillment, queue length 20, and identity system. The identity already has queue data plane permission, so the remaining deployment decision is the scale rule. An Azure Queue custom rule identifies the account, queue, and queue length threshold in metadata and selects the system-assigned identity instead of secret-based authentication. Existing replica limits continue to bound scale actions. Establish target resource authorization separately, then match the scale rule type to the signal and select identity rather than secret-based auth. Question 13 of 32. A company will create a new app service plan before creating a web app. The app has a Linux-only dependency, and company policy requires its compute resources to be created in West Europe. No existing app is being moved. The app's runtime stack will be selected when the web app is created. Which app service plan details should you select? Answer A. Operating system, Windows. Region, North Europe. Answer B. Operating system, Windows. Region, West Europe. Answer C. Operating system, Linux. Region, North Europe. Answer D. Operating system, Linux. Region, West Europe. Lock in your answer. Answer D is correct. Operating system, Linux. Region, West Europe. The app service plan must be created with Linux as its operating system platform and West Europe as its region. The region determines where the plan's compute resources are created, while the web app's language runtime remains an app-level selection. At plan creation, treat operating system platform and compute region as plan properties. Defer language runtime selection to the app. Question 14 of 32. Several web apps share a dedicated app service plan. The plan's current pricing tier cannot provide the deployment workflow and aggregate capacity needed for an upcoming release. The team requires a deployment slot and 8 shared VM instances, and the apps must remain together in their existing plan. Which configuration should the team use? Answer A. Change the shared app service plan to a pricing tier that supports the required feature and capacity, and scale out that plan to 8 VM instances. Answer B. Create another app service plan with deployment slot support and 8 VM instances, and leave the web apps assigned to the existing plan. Answer C. Create a deployment slot for each web app and configure the slots collectively to use 8 VM instances while leaving the plan unchanged. Answer D. Select a slot-capable pricing tier separately for each web app and set the app's instance counts to use 8 VM instances in total. Lock in your answer. The supported answer is A. Change the shared app service plan to a pricing tier that supports the required feature and capacity, and scale out that plan to 8 VM instances. Pricing tier and worker count are properties of the shared app service plan. The team must therefore change that plan to a tier whose feature and scale-out envelope meets the requirements, and then scale out the same plan to 8 VM instances. App-level or slot-level changes do not change the shared plan's pricing tier or worker count, and an unused second plan supplies no resources to apps that remain assigned to the original plan. Apply pricing tier and shared worker changes at the app service plan scope. Scale up for the feature and capacity envelope. Then scale out for the required instance count. Question 15 of 32. 3 web apps share an app service plan. A 4th app will use the same operating system platform and geographical region. Although the existing plan has enough capacity for its initial load, the 4th app must scale independently, have separately owned compute cost, and avoid competing with the other apps for worker resources. Where should you place the 4th app? Answer A. In a separate app service plan with the required operating system platform and region. Answer B. In a deployment slot of one app in the existing app service plan. Answer C. In the existing app service plan because its current capacity is sufficient. Answer D. In a new resource group while continuing to use the existing app service plan. Lock in your answer. That makes A correct, in a separate app service plan with the required operating system platform and region. Apps in one app service plan share VM instances and scale together. A separate compatible plan creates the required compute, scaling, and billing boundary for the 4th app. A slot or resource group change does not create separate workers. Use the app service plan, not a slot or resource group, as the boundary for shared workers and plan-wide scaling. Question 16 of 32. Several apps share an app service plan. Monitoring shows that each worker has insufficient memory for the workloads, and the apps also require a feature that is not included in the current pricing tier. Increasing the number of equally sized workers would not correct either issue. What should you change? Answer A. Change the runtime stack of each app in the plan. Answer B. Increase the app service plan's VM instance count. Answer C. Change the app service plan to an eligible higher pricing tier. Answer D. Create an additional deployment slot for each app. Lock in your answer. Choose answer C. Change the app service plan to an eligible higher pricing tier. Scaling up by changing the plan's pricing tier is the control for obtaining greater per-worker resources and tier-bound features. The plan level change affects every app hosted on the plan. Scale out changes only the number of VM instances, not each worker's capability. When the deficit is per worker or tied to plan features, scale up the plan tier. When only aggregate instance count is deficient, consider scale out. Question 17 of 32. An app service plan currently uses Autoscale rules. For a scheduled processing window, demand is known, and the plan must run on exactly 6 VM instances for the entire window. The current pricing tier supports 6 instances. All apps in the plan should use this expanded fixed worker pool. Which configuration should you apply before the window begins? Answer A. Change the plan's pricing tier while leaving the current instance count and autoscale rules unchanged. Answer B. Create 6 deployment slots across the apps while leaving the plan's scaling configuration unchanged. Answer C. On the resource autoscale page, select Manual Scale. Set the instance count to 6 and save. Answer D. Keep Autoscale enabled, retain its metric rules, and set only the default instance count to 6. Lock in your answer. Answer C is correct. On the Resource Autoscale page, select Manual Scale, set the instance count to 6, and save. Manual Scale removes the autoscale rules and returns the resource to a fixed instance count. Setting that count to 6 produces the required horizontal plan capacity, shared by all apps in the plan without changing the worker SKU. For a known fixed capacity window, switch the resource from autoscale to manual scale and set the supported instance count explicitly. Question 18 of 32. An app service plan currently runs 2 instances. Its approved operating range is 1 through 5 instances. Sustained CPU above 70% must add 1 instance. Sustained CPU below 20% must remove 1 instance. And each rule must wait 10 minutes before another scale action. Administrators need to review completed autoscale events. Which autoscale configuration should you use? Answer A. Use minimum 1, default 2, and maximum 5. Increase the count by 1 for sustained CPU above 70%. Decrease it by 1 for sustained CPU below 20%. Use 10-minute cooldowns, inspect run history. Answer B. Use minimum 1, default 2, and maximum 5. Increase the count by 1 for sustained CPU above 70%. Decrease it by 1 for sustained CPU below 20%. Use 0-minute cooldowns, inspect run history. Answer C. Use minimum 1, default 2, and maximum 5. Increase the count by 1 for sustained CPU above 70%. Decrease it by 1 for sustained CPU below 20%. Use 10-minute cooldowns, inspect alert history for scale events. Answer D. Use minimum 1, default 2, and maximum 5. Decrease the count by 1 for sustained CPU above 70%. Increase it by 1 for sustained CPU below 20%. Use 10-minute cooldowns, inspect run history. Lock in your answer. The supported answer is A. Use minimum 1, default 2, and maximum 5. Increase the count by 1 for sustained CPU above 70%. Decrease it by 1 for sustained CPU below 20%. Use 10-minute cooldowns. Inspect run history. The plan already has 2 instances, so no claim that default capacity forces an initial count is required. An Azure Monitor autoscale profile supplies the approved minimum, default, and maximum values. The high CPU rule increases capacity. The low CPU rule decreases it, and cooldown periods delay repeated actions. Autoscale run history provides the completed scale event record. Alert history is not a substitute for that autoscale history. Evaluate autoscale profiles by capacity bounds, action direction, cooldown behavior, and the autoscale-specific event record, rather than by requirement word overlap. Question 19 of 32. A compatible Linux app service plan already exists. A new web application requires a supported Node.js 24 LTS runtime. The application host must be provisioned before the team deploys its code, and the app must receive its own globally unique service name. Which action should you take? Answer A. Deploy the new application's package to the existing plan first, then create a site only if the deployment does not return an app URL. Answer B. Create a new app service site with a globally unique name. Associate it with the existing plan, and set its site runtime configuration to Node.js 24 LTS. Answer C. Change the existing plan's operating system setting to Node.js 24 LTS, and deploy the new application's package directly to the plan. Answer D. Create a deployment slot under an unrelated existing app. Name the slot for the new application, and set the slot runtime to Node.js 24 LTS. Lock in your answer. That makes B correct. Create a new app service site with a globally unique name. Associate it with the existing plan, and set its site runtime configuration to Node.js 24 LTS. The application needs its own app service site resource. That site associates with the existing plan and carries the supported runtime version in its site configuration. Creating the host is distinct from deploying application content, and a deployment slot belongs to an already existing app rather than replacing initial site creation. Separate the hosting layers. The plan supplies compatible compute. The site supplies app identity and runtime configuration, and deployment supplies content. Question 20 of 32. An app service app uses an Azure SDK credential chain to access a target resource, where the resource team has already prepared an ABAC assignment for the app's workload identity. The code also reads a non-secret deployment label from an environment variable named deployment entry urve. The production app currently has neither an identity nor that configuration value. Which two app-side configurations satisfy the code's runtime dependencies? Answer A. Add only a Microsoft Entra application ID to the app settings and leave the app identity disabled. Answer B. Enable a managed identity on the app service app. Answer C. Create an app setting named deployment end variable with the deployment-specific value. Answer D. Enable app service authentication with Microsoft Entra ID as the identity provider. Lock in your answer. The supported answers are B and C. B. Enable a managed identity on the app service app. C. Create an app setting named deployment env with the deployment-specific value. Enabling the app's managed identity provides the workload identity used by Azure SDK credential discovery. Adding deployment env as an app setting makes that non-secret value available to the running app as an environment variable. App service authentication addresses inbound user authentication, and an application ID alone is not a workload credential. Separate outbound workload identity from inbound user authentication, and use app settings for non-secret values that code reads as environment variables. Question 21 of 32. An app service app is in an eligible pricing tier, and API.contoso.com is already mapped to the app. The company has supplied a password-protected PFX certificate that covers API.contoso.com. The administrator must make the custom hostname available through HTTPS, and then confirm the app service binding state. In which order should the administrator perform the actions? Answer A. Add the eligible password-protected PFX certificate to the app. Answer B. Test https://api.contoso.com and inspect its TLS/SSL state in custom domains. Answer C. Add a TLS/SSL binding for api.contoso.com using the supplied certificate. Lock in your answer. The correct order is: first, add the eligible password-protected PFX certificate to the app. Second, add a TLS/SSL binding for api.contoso.com using the supplied certificate. Third, test https://api.contoso.com and inspect its TLS/SSL state in custom domains. The certificate must first be available to the app. The administrator can then select it while creating the binding for the already mapped custom hostname. After the binding operation completes, the custom domains page reports a secured state, and the custom HTTPS endpoint can be accessed. The secured state confirms a binding, but does not by itself prove that the certificate is unexpired or publicly trusted. For inbound TLS on an already mapped custom hostname, make the certificate available, bind it to the hostname, and only then verify binding state and HTTPS behavior. Question 22 of 32. An App Service app has existing custom hostname and certificate bindings. Security requires every plain HTTP request to be redirected to HTTPS, and every new inbound connection to use TLS 1.3. The existing hostname bindings must remain unchanged. Which two app service configuration actions should you take? Answer A. Set minimum inbound TLS version to TLS 1.3. Answer B. Change the TLS behavior of outbound connections initiated by the application code. Answer C. Renew the certificate currently bound to the custom hostname. Answer D. Enable HTTPS only for the app. Lock in your answer. Answers A and D are correct. A. Set minimum inbound TLS version to TLS 1.3. D. Enable HTTPS only for the app. HTTPS only redirects HTTP traffic to HTTPS. Minimum inbound TLS version sets the protocol floor for incoming requests, so setting it to TLS 1.3 meets the inbound protocol requirement without changing the existing hostname bindings. Separate inbound transport policy into its two controls. One handles the HTTP to HTTPS path, and the other sets the lowest accepted inbound TLS version. Question 23 of 32. An App Service app named Sales App runs in a paid tier and has the default hostname salesapp.azurewebsites.net. You control the public DNS zone contoso.com and must map store.contoso.com to the app. Domain ownership must be verified. TLS certificate binding will be handled later. In which order should you map the subdomain to the app? Answer A. App Service Custom Domain Validation Target store.contoso.com. Answer B. App Service Hostname Binding Target store.contoso.com. Answer C. Public DNS entries store cname salesapp.azurewebsites.net. asuid.store txt with the app's domain verification ID. Lock in your answer. The correct order is: first, public DNS entries. Store cname salesapp.azurewebsites.net, asuid.store txt with the app's domain verification ID. Second, App Service Custom Domain Validation Target, store.contoso.com. Third, App Service Hostname Binding Target, store.contoso.com. The CNAME performs subdomain routing to the app's default hostname, while the asuid prefixed txt record provides ownership verification. App Service can then validate both records, after which the custom domain is added as a hostname binding. For a custom subdomain, distinguish the DNS record that routes traffic from the txt record that proves ownership, then validate before creating the hostname binding. Question 24 of 32. An app service app must be reached at the public DNS zone apex contoso.com. You can edit the zone's records. The Add Custom Domain dialog provides the app IP address and domain verification ID. App Service must verify both records before the hostname is added. Which DNS record configuration corresponds to each requirement? Requirement 1. Route contoso.com to the app. Requirement 2. Prove ownership of contoso.com to App Service. Requirement 3. Identify the record pattern that must not be used for this root domain mapping. Answer A. A TXT record at ASUID containing the domain verification ID. Answer B. A CNAME record at targeting the app's default hostname. Answer C. An A record at containing the app IP address. Lock in your answer. Resolve the map this way. Requirement 1. Route contoso.com to the app matches answer C. An A record at containing the app IP address. Requirement 2. Prove ownership of contoso.com to App Service matches answer A. A TXT record at ASUID containing the domain verification ID. Requirement 3. Identify the record pattern that must not be used for this root domain mapping matches answer B. A CNAME record at targeting the app's default hostname. The supported root domain pattern uses an A record at for routing and an ASUID TXT record for ownership verification. The root domain must not use the subdomain style CNAME mapping pattern. After both required records validate with green check marks, the domain can be added. Before choosing DNS records, classify the requested name as a zone apex or a subdomain. The routing record form changes, but ownership verification remains a separate TXT function. Question 25 of 32. An app service app runs in a standard tier. The business works in 8-hour shifts and permits the loss of no more than half a shift of changes after a recovery. Auditors require recovery points covering at least the preceding fortnight. To control backup storage, use the least frequent schedule and shortest retention that satisfy those limits. The team wants recoverable app content and configuration through the platform's native backup mechanism. Which 3 actions should you include in the backup configuration? Answer A. Use the App Service custom backup feature with an Azure storage destination. Answer B. Use a staging slot as the scheduled recovery copy of production content and configuration. Answer C. Register the app's underlying workers as Azure VMs in a recovery services vault policy. Answer D. Keep custom backup files for 14 days. Answer E. Set the custom backup schedule to run every hour. Answer F. Use a 4-hour custom backup interval. Lock in your answer. Answers A, D, and F are correct. A. Use the App Service custom backup feature with an Azure storage destination. D. Keep custom backup files for 14 days. F. Use a 4-hour custom backup interval. A custom App Service backup uses an Azure storage account and supports configurable cadence and retention. A 4-hour schedule is above the 2-hour minimum, and 14 days is within the supported custom retention range. The standard tier supports App Service backup and restore. For App Service backup, first verify plan eligibility. Then distinguish custom backup storage, cadence, and retention from VM protection and deployment slot workflows. Question 26 of 32. A supported App Service app already has custom scheduled backups configured. The folder %home %backsite /www root/cache contains volatile files that must be omitted from every future custom backup, while all other required application content must remain included. What should you configure? Answer A. Create %home%site /www root _backup.filter and list the cache folder in the file. Answer B. Configure a deployment slot content exclusion for the cache folder before each backup. Answer C. Delete the cache folder from the running app before each scheduled backup and recreate it afterward. Answer D. Restore each backup to a new deployment slot and remove the cache folder from the restored copy. Lock in your answer. The supported answer is A. Create %home%site /www root _backup.filter and list the cache folder in the file. The reserved _backup.filter file in %home%site /www root configures partial custom backups. Listing the cache folder there causes normal custom on-demand and scheduled backups to omit that path from future backup sets, while retaining other content. When only selected app service paths should be omitted, look for the backup-specific exclusion file, rather than changing live content or using restore and slot operations. Question 27 of 32. An app service app must initiate connections to a database private endpoint in a peered virtual network. A dedicated subnet is available for the app and can be delegated for integration. The requirement concerns only app-originated traffic. The app's inbound endpoint does not need to become private. Which app service networking configuration should you use? Answer A. Configure regional virtual network integration by using the dedicated delegated subnet. Answer B. Add an app service access restriction that allows the peered virtual network. Answer C. Create a private endpoint for the app service app in the dedicated subnet. Answer D. Create an app service private endpoint and add an access restriction without configuring virtual network integration. Lock in your answer. That makes A correct. Configure regional virtual network integration by using the dedicated delegated subnet. App Service Virtual Network Integration is the outbound mechanism. It mounts virtual interfaces to workers with addresses from a dedicated delegated subnet. Calls to a private endpoint in the integrated or peered virtual network then use an address from the integration subnet. Determine connection direction first. App Service Virtual Network Integration is for app-originated outbound traffic, while private endpoints and access restrictions govern inbound reachability. Question 28 of 32. A company hosts two app service apps, App 1 and App 2, on supported plans. App 1 must retain its default public endpoint, but accept requests only from specified Office IP addresses. App 2 must be reachable only by clients in a virtual network through a private IP address and must have no public exposure. The company can configure private DNS for App 2. Which configuration should be applied to each app? Requirement 1. App 1. Retain the default ingress path and accept requests only from the specified Office IP addresses. Requirement 2. App 2. Allow only virtual network clients to reach the app through an address assigned in that network, with no internet exposure. Private DNS is available. Answer A. Create an app service private endpoint. Configure the private link DNS name to resolve to its private IP address and disable public network access. Answer B. Keep public endpoint access enabled and configure site access restriction rules for the Office IP addresses. Lock in your answer. Resolve the map this way. Requirement 1. App 1. Retain the default ingress path and accept requests only from the specified Office IP addresses matches answer B. Keep public endpoint access enabled and configure site access restriction rules for the Office IP addresses. Requirement 2. App 2. Allow only virtual network clients to reach the app through an address assigned in that network, with no internet exposure. Private DNS is available. Matches answer A. Create an App Service private endpoint. Configure the private link DNS name to resolve to its private IP address, and disable public network access. Access restrictions filter requests that continue to arrive through the public endpoint, which fits App 1. A private endpoint gives App 2 a virtual network IP address. Private DNS must resolve its private link name to that address, and disabling public network access removes public exposure. Choose inbound controls by deciding whether the public endpoint stays available and filtered or is replaced by private address reachability with public access disabled. Question 29 of 32. An app service app has production and staging slots on the same app service plan. Each slot uses a different API background URL app setting and a different OrdersDB connection string. A staging to production swap must move the application version, but must not move either environment-specific value between slots. Which two actions should you take before the swap? Answer A. Move the staging slot to a separate app service plan. Answer B. Mark the OrdersDB connection string as a deployment slot setting. Answer C. Mark API board URL as a deployment slot setting. Answer D. Set the staging slot's traffic percentage to 0. Answer E. Inspect the source slot and target slot changes in the swap dialog without marking either value as slot specific. Lock in your answer. The supported answers are B and C. B. Mark the OrdersDB connection string as a deployment slot setting. C. Mark API base URL as a deployment slot setting. Selecting deployment slot setting marks an app setting or connection string as not swappable. Marking both environment-specific values keeps each associated with its current slot when the application version is swapped. When a swap should move code but not an environment-dependent value, mark the individual app setting or connection string as slot-specific, rather than changing traffic or compute placement. Question 30 of 32. A warmed staging slot contains a release that has passed initial testing. Site authentication is disabled in both staging and production. The team must review configuration effects, validate the preview before promotion, and retain the former production version in staging for rapid reversal if needed. In which order should you perform the controlled slot promotion? Answer A. Choose staging as the source and production as the target and review the swap changes. Answer B. Exercise the staging slot and verify the configuration presented by the preview. Answer C. Initiate swap with preview. Answer D. Commit the slot swap. Lock in your answer. Use this sequence. First, choose staging as the source and production as the target, and review the swap changes. Second, initiate swap with preview. Third, exercise the staging slot and verify the configuration presented by the preview. Fourth, commit the slot swap. The administrator first confirms staging as source, production as target, and reviews the expected changes. Swap with preview then pauses after its first phase, so the result can be validated on staging. Completing the swap promotes the warmed staged app and leaves the former production app in the other slot, allowing an immediate reverse swap if rollback is required. A preview-based release separates review, paused application of swap changes, validation, and completion. Rollback remains possible because the prior production version moved to the other slot. Question 31 of 32. An app service app must access an Azure storage account without using the storage account's public endpoint. App Service Virtual Network integration is already configured, and the app can reach resources in the integrated or peered virtual network. The app uses a managed identity, and the organization has selected Azure ABAC for the required storage data operation. During staged implementation and validation, the team records 4 findings. Public access will be disabled only after the private path is proven to work. Which action should the team take for each finding? Requirement 1. The app can send traffic through its integration subnet, but the storage account still has no target-side connection or address in the reachable network. An engineer proposes adding an endpoint to the app itself. Requirement 2. A connection to the approved endpoint's numeric address succeeds. The storage account's standard service name still sends the app to the public address. Requirement 3. The standard service name reaches the private address and the network connection succeeds. The data request is then denied for the managed identity. Requirement 4. End-to-end tests now pass over the private address, but a client outside the virtual network can still initiate a connection through the public address. Answer A. Grant the managed identity the required Azure ABAC data role at the storage account scope. Answer B. Change the name resolution path used by the app so the normal service name returns the endpoint address. Answer C. After the successful private path checks, apply the storage account control that blocks its public network path. Answer D. Provision the Azure Private Link network interface on the storage account and complete the resource owner's connection approval. Lock in your answer. The correct matches are Requirement 1. The app can send traffic through its integration subnet, but the storage account still has no target-side connection or address in the reachable network. An engineer proposes adding an endpoint to the app itself, matches answer D. Provision the Azure Private Link network interface on the storage account and complete the resource owner's connection approval. Requirement 2. A connection to the approved endpoint's numeric address succeeds. The storage account's standard service name still sends the app to the public address. Matches answer B. Change the name resolution path used by the app so the normal service name returns the endpoint address. Requirement 3. The standard service name reaches the private address and the network connection succeeds. The data request is then denied for the managed identity. Matches answer A. Grant the managed identity the required Azure ABAC data role at the storage account scope. Requirement 4. End-to-end tests now pass over the private address, but a client outside the virtual network can still initiate a connection through the public address. Matches answer C. After the successful private path checks, apply the storage account control that blocks its public network path. App Service Virtual Network Integration is already the app's outbound path, so an App Service private endpoint would address the wrong traffic direction. Provision and approve the private endpoint on the target storage account. If the standard service name still reaches the public address while the private IP works, configure the private DNS path. If private connectivity succeeds, but Azure ABAC denies the operation, assign the app identity the required data role. A private endpoint does not itself disable public access, so apply the storage account's public network restriction after private validation succeeds. Trace a private service call by direction and state. Source-side outbound integration. Target-side endpoint and approval. Private name resolution. Identity authorization. And separate public access restriction. Question 32 of 32. A container workload uses virtual network VNet app for DNS. The private namespace corp.contoso.com is hosted by an on-premises DNS server at 10.100.0.2, which is reachable through an Azure DNS private resolver outbound endpoint. No private DNS zone will host this namespace. You must conditionally forward matching queries from the workload to the on-premises server. In which order should you configure and verify DNS forwarding? Answer A. Forwarding rule set virtual network links, VNet app. Answer B. Resolution observation point and name, a container in VNet app, host.corp.contoso.com. Answer C. Forwarding rule set definition. Outbound endpoint association. Enabled. corp.contoso.com. Rule. Destination. 10.100.0.2:53. Lock in your answer. Use this sequence. First, forwarding rule set definition. Outbound endpoint association. Enabled. corp.contoso.com. Rule. Destination 10.100.0.2:53. Second, forwarding rule set virtual network links. VNet app. Third, resolution observation point and name. A container in VNet app. host.corp.contoso.com. The outbound endpoint must be associated with a rule set containing an enabled .terminated namespace rule and the destination DNS server IP and port. Linking VNet app makes resources in that network use the enabled forwarding rule. A query from the workload then verifies the resolver to rule set to on-premises path. Conditional forwarding requires a reachable outbound resolver path, an enabled namespace to DNS server rule, and a rule set link to the querying virtual network. Verify from a resource that uses that link. Confidence check. For each managed application or container decision, identify the hosting boundary, the deployment control, the network or identity path, and the operational evidence you would verify. If you can explain those 4 things, you are building administrator-level judgment rather than memorizing clicks. Thanks for practicing with WebLizard Labs CertLab. Keep tracing deployment boundaries, image and revision controls, ingress paths, identity, scale, and recovery evidence.